This is the overhead cam drum on this model machine. The purpose of the cams is to control the machining cycle. A roller passing over the cams moves the tools in and out of the work. The approach portion brings the tools quickly towards the bar stock. This is the low point. The tools are about to cut into the work. The feed portion causes the tools to cut the stock. At the dwell or high point, the cutting is complete. This cam is used on more recent models. This is the approach, low point, feed portion, and high point. The rise of a cam is the vertical distance between low point and high point. Each cam is marked with the amount of rise. Your layout sheet will indicate the proper location of each cam. This is the rapid approach portion of the cycle. This is low point, or the beginning of the feed portion. As the tools start to cut, chips are produced. At the dwell, the tools are allowed to finish cutting before they are withdrawn, and then the cycle starts over again after index. The adjustment of the stop tension is usually done during setup. If the high point of the cams you use on your machines always occurs at the same location, it would not be necessary for you to readjust stop tension when the cams are replaced. The amount of stop tension needed on the cross slide will vary. The Conomatic has single and double cross slides. The double cross slide has 2 tool holders mounted on it. Because of this, it will need more stop tension on the cross slide operating mechanism to be sure the cross slide stops at the same point during each cycle. The double slides have 2 stop tension adjustment nuts. To set cross slide stop tension, you will need to jog the machine to the high point of the new cam. Now you can tighten the cross slide stop tension adjusting nut until the selective stop screw comes in contact with the plate behind it. If you are working on a double slide, you should tighten the other adjusting nut at the same time. Neither nut should be fully tightened, however. There are also nuts on the other side of the cross-slide casting that you may need to back off. As you turn the adjusting nut, each flat or 1/6 of a turn on the nut will produce about 10 thousandths more tension on the cross slide. The manual for the model Conomatic machine you are operating will give you the correct amount of stop tension for the slides. Notice the difference between the machine surfaces on these 2 parts. The surface of the part on the left is smooth, while the part on the right is uneven and rough. Chatter causes the uneven, rough surface. Vibration is the primary cause of chatter. When this vibration occurs, the cutting tool is not able to maintain a constant and even pressure on the stock. This results in an uneven or rough surface on the finished parts. Knowing that vibration is the primary cause of chatter does not solve the problem. As an operator, you must determine what causes this vibration. In this case, the cross-slide hold-down bolts need to be tightened. Once they were tightened, the chatter disappeared. The most common chatter problem is caused by the forming tools being positioned below the center line of the part. When the cutting tool is properly positioned, the cutting edge will be flush with the top of the tool holder. Dull cutting tools are also a cause of chatter. When a tool becomes dull, it will drag or bounce on the stock rather than make a smooth cut. The purpose of die head threading is to cut threads on the outside diameter of pieces. This television training tape will show you the correct procedure for setting up the die head threading attachment. Before setting up the attachment, you must understand how the die head works. The die head is mounted to the rotating auxiliary spindle. The auxiliary spindle is advanced as the turret tool slide comes forward. The auxiliary lever also causes forward movement of the auxiliary spindle. The spindle is rotating at a speed determined by a set of gears located next to the feed gears in the gearbox. As the die head is moved forward by the auxiliary lever, the chasers cut into the part and produce the threads. When the proper depth of the thread is reached, the die head opens and is pulled back over the newly cut threads by the return spring. This yoke is what causes the die head to open and close at the right time during the threading cycle. The die head is closed by the yoke when the turret tool slide withdraws. A special cam called a kicker cam is mounted on the auxiliary cam drum. The cam applies pressure just as the chasers contact the part. This pressure causes the chasers to cut into the part.